Well, good morning, students. I hope everyone is doing good. Today we're going to continue on in our lesson studying circuitry within technology. You remember last week, if you were able to watch the video, we were taking a look at what's called Ohm's law, seeing the relationship between the three components of electricity: voltage, amperage, and resistance. We looked at, hopefully you did, hopefully you went to the link from the simulator at the University of Colorado, and I know I worked through that with a few of you over Zoom, but hopefully you got a chance to play around with that. So today we're going to continue in that same concept of dealing with circuitry, except today we're gonna break it down for its symbols. So last time we introduced the simulator and work through the relationship between voltage, amperage, and resistance. But today I want to teach you what the symbols are, so that as you make future circuits, you're able to tell what components go where. And if you learn this well, you'll be able to read a circuit diagram and create a circuit diagram. I'm also going to have a video linked, YouTube video that explains same mechanics that I'm going to talk through here, and you can watch that. And then we're going to work through a couple examples. One that's going to show us the symbols with a quiz that you can take and try to match them up on your own. And then we'll go back into our simulator and I'll show you the difference between the physical representations for the battery and the light bulb and what those correspond to in terms of a circuit diagram. Okay, last thing that I want to challenge and encourage you guys to do while you are there at home working through this is to continue exploring conductivity. I left off last week showing you that in the simulator there were some other tools over on the left side. I think one of them was a hand, one of them was I think a pencil, one of them was a dog, and was encourage you to play with those. We're going to do something a little similar. I'll have another link you'll be able to click on that will allow you to continue to experiment with conductivity. So that's the plan. We're going to focus directly on circuit diagramming and learning the shapes and symbols, and then I'll have you guys work through that in the simulator, and we'll conclude our time with continue to explore conductivity. Of the symbols that you're going to need to know, the first and probably most important one is going to be the power source, so the battery. And that is drawn by a wire with two lines, one small and one large. So I'll draw it here in a minute so you can see it. The main thing to remember as we're drawing the power source is which end is positive and which end is negative. And that will tell us the flow of the current and then inversely the direction of the electrons. So I don't know if you caught that from last week, but current always flows from the positive to the negative. I find that it's just easy to remember that, thinking that the positive has more, and so it gets, you start with the positive and you go to the negative as though the negative had less. Intuitively, it's actually in the reverse when you're talking about the electrons, because electrons, being a negatively charged subatomic particle, are all contained in the negative, and like charges repel one another, so the negative is going to repel and actually going to move towards a positive. So when we're thinking of the flow of electrons, they're going from that repository of negative charges to the positive. But when we're talking about the flow of the current, now we're talking about going from positive to negative. The reason why this is important is many times within circuitry, you're going to have to make sure you have those currents moving in the right direction. And so when we do circuit diagramming, we have to make sure that we're properly labeling where the positive terminal and where the negative terminal are. So we'll talk about that in just a second. The other two components that I want to make sure that you're super familiar with are a resistor and whatever's going to take the load. In our case, it's going to be a light bulb. And the reason why I want to just draw your attention to those is because sometimes, depending on the diagram, you will have different symbols for each of those. So a resistor will sometimes look like just a rectangle box in some diagrams, and then in others it'll look like a little squiggly line. So resistor can take those two different forms, and then a light bulb in some circuit diagrams is going to look like a circle with an X through it, and in others it's going to look like a circle with this little bitty bulge in it. And both of those are referring to the load drawn in a circuit for a light bulb. I'm going to draw those for you, and maybe you could take out a piece of paper and you can practice drawing them yourself. And then I'm going to introduce just a couple of other ones. A switch, which we've looked at, very simple, and then two forms of a diode, which we will look at as well. So take out a piece of paper. You can draw these along with me now. Okay, here is a list of the symbols that we are going to learn, and I'm going to show you now. So we'll start over here, first one with the battery. When we draw a battery, they look like the line coming in, and then from the negative side, you'll have one line there, and then a parallel long line for the positive. So for this symbol for a battery, this would be the negative, this side would be the positive, and I'll just draw that again here with reverse. We'll draw the positive first, which is the long side, and then the negative is a shorter little line right there. So positive on this side, negative on this side. And that's it. That is the circuit diagram symbol for your power source for a DC or direct current battery. Now, switch is something that we've looked at many times. We're going to start by drawing our wire and a node, and then the other intersecting wire there, and the switch, you just put a little line just like that. And so this would be an example of a switch that is open. And if you wanted to show your switch being closed, you would just draw the almost exact same thing, except instead of the line going up, the line goes straight through to show that you are now closing the circuit. And that's how you draw a switch. A resistor, we draw our wire line coming in, put our node on the outside for where that's going to connect, and then the first one is going to look like this long rectangle. So that is one example of a picture of a resistor. The second one is very similar, except it has this squiggly line just up and down like that. So both of these are examples of circuit diagrams for resistors. Now, when you're drawing a circuit, you're going to have something that will be represented as a load, and the most common one that we'll use is a bulb. I think it's kind of fun to draw, but it's a little bit tricky. You have to practice it a couple of times. So first thing you do is draw your node on the outside, and then your line coming to the bulb, and then you're going to draw a full circle back to where you started, and then right in the middle, you're going to draw this little just a little loop, half circle on the inside. That is what the symbol for a bulb looks like. Now, on some diagrams, they're going to make it just with a circle, and they're going to put an X through the middle like this to represent a bulb. So these are the two different symbols that you'll recognize if you're looking at a circuit diagram for a bulb. A motor is very similar. It's also going to have the picture of a circle, but this time, again, if it's something spinning or some type of a motor, we'll just put the letter M in the middle to tell us that we're dealing with a motor. All right, lastly, let me really introduce two new components here. I don't believe that these are on our simulator, but they're going to be ones that we're going to reference in the future, and they are two different kinds of diodes. Now, a diode is a limiter for current that only allows it to flow in one direction. If the current tried to flow the opposite direction, it would be stopped. So what a diode does is it only allows the current to flow in one way. And the picture of a diode, in order to show us the direction, is going to look like a triangle that's an arrow pointing in the direction that it flows, with a line in the front showing that it won't go this way. So in this case, the current flow through the diode would be in this direction. So this looks like a little triangle with a line there on the front of it representing the flow of a current. So that's a diode. And then the last one is a light emitting diode, or you might actually know this by a different name as a LED light. So this is another kind of light bulb, but we're not going to have the same signal as we will for the bulb over here because they actually are having a different physical process as to how they are emitting light. Even though both of them are emitting light, this one is actually a diode. So we're going to draw it very similarly to the one we just drew. We're going to have that little triangle symbol with the line showing the direction, but then for an LED, you're going to draw these two little arrows coming off that show that it's actually emitting a photon, it's emitting light. So this is the symbol for an LED or a light emitting diode. All right, hopefully you were able to draw those along with me, and now we're going to go into our a little quiz where they're represented and to see if we can identify them within a circuit. Okay, here is the first link that I'm going to send below, or where you're able to watch this video so that you can practice memorizing and then identifying these different symbols for a circuit diagram. So you're going to see a few of them just as I drew them. The first here is the battery, and you'll notice here the short dark side is attached to the negative terminal, and the long flat one is attached here to the positive side. They have a few other, one here that I didn't draw, which is a connecting wire. This would be a junction where now it's going to be running in parallel. We're going to talk about that in a future video for the difference between parallel and series, but we won't worry about that for right now. Here are the two examples for a switch. Here is one of the symbols that we've used for a bulb, the picture here of a resistor, and then a diode. One other thing to point out with a diode is that you'll see here is a little silver band on the diode itself, this physical representation. If I could zoom in right here, you'll see the silver band, and that is determinative of the direction of the flow. So again, a diode is limiting the flow to only one direction, and here with the triangle you'll see that it is going this way. So it's here going from the left to the right, and that's also represented here physically on the diode itself. For a LED, here is the symbol. You'll see the two little arrows here that are helping us know that this is a diode that is emitting light. And then finally, the picture of a motor here that's spinning with the capital letter M. Okay, these are 8 symbols. I am hoping that you are able to learn these and master them for today's lesson. And now I'm going to walk you through the quiz here to see if you can do it. I'll go through the first 2 and then I'll let you continue on, do the rest yourself. So I'm going to click the little play button right down here in the corner. All right, so here is our physical representation, and what we're going to do is we're going to overlay this with the diagram and see if we can match them up. And I want you to remember, pay close attention here to the positive and negative terminals. So we're going to click this button to start circuit diagram. And here we go. They have it laid out here with some nice sharp corners for our wires. And here is our bin that we're able to choose from what we think the right symbols are. Excuse me. So the first one, you'll see 2 different, one representing the battery. We have one right up here at the top and one here in the middle. Which do you think goes here? Well, I remember telling you that the little negative is the fat little one here, and this is the positive. Positive is also always represented by red and negative by black, and you'll see the symbols also here on the battery itself. But let's say instead of using the correct one, which would be this one, let's say I put this one. I'm just going to click and drag it over here right now. So let's say that was the one I was trying. A couple other ones. Here's our switch. The symbol for a switch that is open is it's a letter O here, right? This is open. And then there's a line. Unfortunately, it's a little bit hard to see, but just a straight line here. If this was clicked down, that would mean that the circuit is closed. Right now, it is open, so there's no connection between these 2 terminals with the way it's set up right now. And that's really the only switch we have is an open switch right here. So we're going to take that and drop that in. And then here our picture for the light bulb. You remember that it's not the M for a motor, but it's this X symbol. And we'll drop that in right here as well. Now, once you have these three, we can click verify to see if we did it correctly. And notice it says this is not the right diagram. Click cancel to try again. Now, I suspect our switch is correct, our light is correct. I think our problem is right here, that we have the current flowing in the wrong direction according to the battery. So we're going to click cancel, and let's try it one more time. Let's put our switch where it belongs. Let's put our light bulb where it belongs. And this time, let's make sure we match up the positive side with the positive and the negative with the negative. So let's choose the proper one and click verify this time. And there we go. This is a good diagram. We can click next to continue. So if I click to the next one, you're going to see this one looks very similar to the one that we just did, except this time instead of a light bulb, we have a motor that's spinning. So if I click the circuit diagram, here it's going to overlay once more in the bin options for me to choose from. And you'll notice something different this time with the switch. So here, instead of having the circle depressed for it being open, now we show this straight line. And this is representative of a lot of electronic devices that have a power switch. Many times they'll use these same two symbols showing this straight barred line here to show that you're actually closing the circuit for the switch or turning the device on at this point. And that is the same that we have represented here. So I will leave this for you to try in the links below, so that you can open this up. One point just to make sure that if you're on a Chromebook, this should work just fine. The only problem with this link for the website is that they're using Flash, and so Flash being an older technology for coding that sometimes is not as secure as what they use in other programs for today, you might have to enable it on your computer to get this to work properly. So just a heads up that as you click the link here to practice completing these circuit diagrams, that you might have to make sure you have Flash enabled. All right, now we're going to go back into our simulator and we'll click on Intro again. You'll remember this from last week. I'm just going to show you here the two differences between the physical representations and then this button, which is a diagram. So let's start by drawing a simple circuit. We'll bring our battery over. We'll add our switch to it right away. And actually, I'm going to put a wire in between these two just so that we can make a cleaner diagram here. So put a wire in between those two. We'll attach a wire to this side of our circuit. And then a wire moving over this way, add a light bulb, connecting wire, and then one more right here. Boom. All right, now if I were to switch it over, instead of looking on this side that's showing us the physical representations, if I click right here, it will give us the circuit diagram. And sure enough, you will see some of the very same symbols that you have learned. You'll see our power switch right here with our positive on this side, negative on this side, our open switch diagram right here, the wires that connect, and then here is maybe a little bit of a different symbol, but you'll see that circle, again with that little half circle or semicircle in the middle representing the bulb. I also want to draw your attention over here to the resistor. Resistor symbol here looks like that squiggly line. That's still the symbol for a resistor here. In fact, if we were to unlink these and then just drop one of our resistors in, you'll see, there you go. That's the circuit diagram. If I close the switch, you will see the flow of electrons here. And notice that the flow is moving from the negative to the positive, right? So our negative here is actually showing where the electrons are flowing. But when we want to look at the conventional flow for current, all I have to do is go up here to the top and switch it from electrons to conventional, and you'll see now it's showing us the flow of the current actually going from positive to the negative. All right, I will encourage you to go in here and see if you can draw a couple or create a couple of different diagrams. Put one with a couple of resistors, add the light bulb to it. What would happen if you put in more than one switch? And I want you to see how this looks on the diagram symbol so that you are able to competently read a circuit diagram according to its symbols. All right, this is the last link that I want to give you, and for here I want you to practice completing this circuit. So here's our battery connected to a lamp, and I want you to use these different examples here. So the copper wire here at the top, you can just click it and drag it right in. And if we click and drag it right in here, you will notice, as we have seen with our other wire diagrams, this completes the circuit. And so down here at the bottom, it turns the light on, and if I remove it, it gets dark again, put it back in, the light turns on. So this completes the circuit. We have some other materials, and I'd love for you just to try each one and make a prediction as to whether you think it will close the circuit or not. So here is a metal alloy, and then two wires placed in water and then in salt water, and you can just grab these, drag them right over, and see what happens if the bulb turns on. And then some other physical materials here for learning about conductivity: glass, wood, graphite, aluminum, plastic. We will revisit some of these subjects just as you can experiment here when we get to the subject talking about capacitors. So that'll come up in the future. But I'll put this link down below so that you can experiment and see how it works with different materials and their conductivity. Okay, students, that is all for today. If you can navigate to the page where you found the link for this YouTube video, you should also be able to see there on your Schoology account the links that I put in for you to do the experiments, both for the one for the quiz, for diagramming and identifying the symbols, and then the simulator that we used last time so you can practice creating some of your own, and then lastly, that experiment for connectivity. All right, that's it for today. I will hopefully see you on Thursday. Hope you get a chance to work through some of these topics, and we'll spend a good time talking then on Zoom. Hope you guys stay safe and have fun. Bye.